Okay, some pretty simple margin of error questions that you'll sometimes see. We'll say that they conduct a poll. And we'll say that they're asking, voting on two people for president. You've got Charlie, who's polling at 52%. Sally is polling at 48%. But they have this margin of error that is usually given with a poll. And what the margin of error here is for this one is plus or minus 3%. The question of what is a margin of error? Well, when you poll people, there's always the understanding that's not a perfect poll. You're not necessarily getting a perfect sample or a perfect representation of the larger whole. It's impossible to ask everybody in many situations their opinion on something. If there are thousands upon thousands of people, it's hard to get everybody's attention. Usually you have somebody that you just can't reach, or for whatever reason, you just can't get them. So what people do is come up with a sample to try to match the population. They'll survey the sample, which is possible. But the question is, does the sample truly reflect the population? And there's different measures that go into getting it to measure the population, but it's never perfect. So that's your margin of error. So the question is twofold here. What's the range of possible percentages? Okay, we'll do this first. Range of possible percentages. Very, very simple. Now, there's a formula for margin of error and all that. This is not the goal of this video. This video is just to kind of grasp what it is. So for Charlie, he's polling at 52%, but it may be as little as 49%. And as high as 55%. If that margin of error was 3%, and it overestimated by the full 3%, which is possible, which would be one extreme, Charlie could be as low as 49. But if it underestimated him by the extreme of 3%, then he'd be 55. So Charlie would know somewhere in there. Meanwhile, Sally, on the low end, she would be 45. And I don't know if I actually said it, but all I'm doing is adding and subtracting 3. 52 minus 3 is 49. 52 plus 3 is 55. So Sally did the same thing. And she is somewhere in this range. So question one, range of possible percentages, all you do is add or subtract. And B, you'll often be asked, is there a clear winner? Well, Charlie probably wins. If you look at this 52 and 48, chances are it's something close to that, and he's probably going to get a narrow victory. But there are some scenarios. If the poll overestimated Charlie by and underestimated Sally by that same amount, it's possible that, for example, she could be 51 while he was 49. So there is some overlap of these two percentages. So is there a clear winner? No. You certainly, if you were projecting who will win, you'll certainly say Charlie, and he probably will. But it's not guaranteed looking at these numbers. So the margin of error, again, the concept is what we're after here. The computations are very simple. I'm going to look at one more possibility. Change the, try to keep these questions here. I'm going to change the question a little bit. This time, we'll change the margin of error to, say, 2.5. Put a decimal in there. That's one way that will change. And this time, we'll say that 72% of those surveyed, 72% of people, we'll say, prefer a city park. It doesn't have to be political. It could be anything with a percentage where, again, but the idea is you're surveying people, you're getting people's opinions. Okay, you're not able to ask everybody. So 72% of those surveyed preferred the city park. So the question is, what's the range of possible percentages? If you establish, and there's a way to establish this, which is beyond this video, what's the range of possible percentages here? Well, you would subtract 72 minus 2.5%, that's 69.5%. And it could be as high as 72 plus 2.5, 74.5%. I just wanted to show that, we'll call this number 2. I wanted to show that this doesn't have to be person A versus person B. It could be just some other poll of some sort. Now, this wouldn't make sense anymore. This question, is there a clear winner? You might say, does a clear majority support the park? And in this case, yes, a clear majority would support the park because at least 69.5, that's minimum, 69.5% would support it. So yes, of course, 50.1% would be a majority as long as you're bigger than 50. So again, simple concept, simple computations. The idea here is if you're polling people, you can't ask everybody. And because of that, the sample does not always or will never actually perfectly model the population. So you're going to have a margin of error. How do you come up with a range of possibilities and what can you infer from that is the idea here.